All right, you guys are going to enjoy this. I put a lot of work into this review, so I hope it helps. All right, let's. This is all chapter 4, by the way. So some of the stuff from our quiz, hopefully, we've reflected on it long enough, and some of it seems easier. It always seems easier the second time around. Who knows? But here we are. We're going to talk about some of it again. So, number 1, a fair die is to be rolled, and a random variable x is defined to be -1 if the result is a 1. 2 if the result is a 2 or 3, and 5 if the result is a 4, 5, or 6. Find the density function of x. So remember, density function just means a table, basically. A density function is a table where you have your random variable x, and then the probability associated with that. So our random variable x, it tells us what it is. It's defined to be -1. Okay, if the result is a 1. It's defined to be 2 if the result is a 2 or 3, and it's defined to be a 5 if the result is 4, 5, 6. So it tells us what the random variables are. It's just some random numbers it decided to give us. And now the probability of that. Now, since we're rolling a die, and a fair die that is, each outcome is a 1 out of 6 chance. So if -1, my random variable comes when I roll a 1, well, a 1 only shows up 1 out of 6 times, right? There's a 1 in 6 chance I roll a 1. So the probability for -1 would be 1 out of 6. For 2, as a random variable shows up, the result is a 2 or 3. So that's a 2 out of 6 chance, or a 1/3 chance if you want to write that, but that's the probability for 2. And a 5 of the result is a 4, 5, or 6. So 5 is obviously 3 out of 6 chance because there's 3 different outcomes. Those 3 outcomes would make the random variable 5. So 3 out of 6, or 1/2. But that's your probability density function. That's all it's asking, by the way. Probability density function just wants a table. So a box contains 3 red balls and 2 green balls. 3 balls are selected simultaneously and at random. And a random variable is defined to be the number of green balls. Find the density function of x. So again, density function of x, we're only looking for a table here. So tables are random variable and then the probability of that occurrence. So our random variables. Now our random variable is defined as the number of green balls. Now remember, you're choosing 3. There are 2 green balls. There are 3 red. So it's possible that you choose 3 balls and none of them are green, right? They could all be 3 red and 0 green. So you could have 0 green you pick. It's possible that one of those is green. You could choose 2 red and 1 green. Or you could choose 2 green and 1 red. Now, you are choosing 3 balls. However, there is not a 3rd green ball, so it's not possible to choose 3 green balls. It's only possible you can max out at 2. So these are the only possibilities that we encounter. Now, the probability for these is interesting. So first, you want to find out the total number of ways you can pick 3 balls out of the total that are 5 that are there. So this is a combination. Combination problems come when you're choosing a certain number of things out of a certain number of things. So there are 5 balls in this box, and you're going to just pick 3 of them. So if you want to know the total number of ways to pick 3 out of those 5, it's a combination of 5 choose 3, right? This is the total number of total number that are in the box, and then this is how many you're picking from it. So this will tell us the total number of ways you can choose 3 of those 5. And I believe that number is 10. So there are 10 ways in total. All right, so now so each of these is out of 10. Out of 10, out of 10, out of 10. Now how many of those ways are 0 green? How many of those ways are 1 green? How many ways are those? 2 greens. So for 0 green happens when you have 3 red and 0 green. So the combination for that, remember, you have a combination, and you're choosing 3 red. So there are 3 red to pick from, and you're choosing all 3 of them. So this is the total number of red, and this is how many you're picking for this particular circumstance. So combination 3 choose 3, and then multiply that with the combination of choosing green. Now you're not choosing any green. There are 2 in the box for you to pick, but you're choosing none of them. So it's a combination of 2 choosing 0. Again, that first number is the total that are in the box, and then 0 is how many you're actually choosing. And let the calculator work that out, and I believe it's just 1. So for 0, the probability is 1 out of 10. For 1 green ball, so 1 green ball means you would have 2 red and 1 green. So in that circumstance, you would be choosing a combination of 2 red. So remember, there are 3 red to pick from, and you're choosing 2 in this circumstance. I'm going to multiply that with the 1 green that you pick. So there are 2 green to pick from, and you're picking 1. So again, that says there are 3 red, and I'm picking 2. There are 2 green, and I am picking 1. So that is, I believe, 6 out of 10. So 6 out of 10. This equals 6. But remember, all of these are out of 10. So probability for 1 is 6 out of 10. And then lastly, 2 green. So 2 green comes if you choose 1 red and 2 green. Because remember, you're choosing 3 to begin with here. So 1 red and 2 green. So combination, there are still 3 red to pick from. You're picking one of them, and then multiplying it with a combination of 2 green to pick from, and you're picking both those greens. So this should be 3 times 1, which is just 3. So the probability for 2 would be 3 out of 10. So you would have probability would be 1 out of 10 for that, and then this would have been 6 out of 10, and this number 2 would have been 3 out of 10, which 1, 6, and 3 all add up to 10, so 10 out of 10, just to verify that we've accounted for all 10 possibilities. All right, suppose Lexi, not Mary Beth, attends math class at random, and the probability of attending each class is 0.6. The instructor takes attendance 3 times and awards 10 points to students who attend at least twice, and no points to students who attend less than twice. Random variable x is defined as the number of points Lexi, again, emphasizing the point, not Mary Beth, receives based on attendance. Find the probability density function of x. By the way, guys, I do not make these problems, okay? I just found this problem right off the internet, just copied and pasted it right into this, did not touch it one bit. So I don't know if there are any weird coincidences you notice, but I have nothing to do with it. So anyway, moving on. So we're creating a density function for x. That's what it's asking for. Remember, density function is a table, just a table. So it's just a random variable x and then the probability associated to that. So we're going to complete this table, and that'll be my answer. Now, random variable x defined as the number of points that Lexi receives. Now, Lexi only has 2 possibilities. She can either receive 10 points if she attends class at least twice, or no points if she attends class less than twice. So it's either going to be 0 points for Lexi or 10 points for Lexi. There's not 5-point option. There's not a 20-point option. It's just she's going to get 10 or she's going to get none. So those are our random variables. The hard part is the probability, of course. So we've done this question a couple times. It was on the last quiz review and the last quiz as well. I think it might have been the same. I don't remember if it's exactly the same or not. I know the names are different, but again, I have nothing to do with that. But hopefully you remember. So this is a Bernoulli. It doesn't say in the problem. It kind of should, but at the same time, this is a Bernoulli process. Bernoulli process is when you have basically a win-loss scenario. You have only 2 outcomes. You either come to class, you don't come to class. You either pass the class, you either fail the class. It's a 50, not a 50-50, but like only a 2 outcome circumstance. It's one way or it's the other way. So it's the Bernoulli because, Lexi's either going to class or she's not going to class. So that's what makes it Bernoulli here. All right, so Bernoulli formula is a combination of n choose r, and then the probability to the r power, probability of success that is, and then probability of failure to the n minus r power. So remember, n is your total number of trials, in which case n is always going to be 3, because we're talking about the instructor takes attendance 3 times. So Lexi has 3 opportunities to go to class. R is just going to depend. R varies because R is basically the number of successes or the number of times tried. So Lexi could go to class 0 times, 1 time, 2 times, or all 3 times. So R is going to be different in all these different problems. We'll plug in the different R's and find the probabilities for those different occurrences. P is always the same thing. P is probability of success, and there's a 0.6 probability of success, which means Q is 0.4. So remember, Q is always the opposite of P. So it's always 1 minus that. 1 minus 0.6 is Q. Both P and Q added up should always equal 1. So if you know one is 0.6, then you know the other is 0.4. If P was 0.8, then Q would be 0.2. Okay, just emphasizing that point. You know that together they make 1. All right, so all that's really going to change here is the R. So Lexi's going to get 0 points if she attends class less than twice. No points to students who attend less than twice. So that means attending class 0 times or 1 time is going to land Lexi 0 points. Now, if she attends class 2 times, she'll get the 10 points. Or if she attends class all 3 times, she'll still get the 10 points. So let's start doing some of the math here. So I want to find the probability that Lexi attends class for each of these possibilities, 0, 1, 2, and 3. So we'll do these one at a time. So let's do 0 first. So 0 times attending class. That's a combination of n, which is 3. That's always going to be 3 here. Choosing r, which is 0, because we're talking about 0 times going to class for Lexi. P again is 0.6. It's always going to be 0.6. R, as we just mentioned, is 0 in this case, so it's going to be 0.6 to the 0 power. And then Q, which is 0.4 to the n minus r. So that would be 3 minus 0. 3 minus 0 is 3. So calculate that. And that's our total for probability for Lexi going to class 0 times. I'm going to go ahead and do that. So give me a second. I haven't got my calculator. I don't have it on the screen. I tried really, really hard to get it on the screen, but I couldn't. So it is what it is. But remember, in the calculator, you go to what was it again? Math button. Scroll over to the probability tab, and then the third option down says NCR. So we're going to choose that. N is going to be 3, and then the R is going to be 0. Then we're going to multiply that to the 0.6 to the 0 power, and then multiply that to the 0.4 to the third power, and that equals 0.064. So that is the probability that Lexi goes to class 0 times. Now, if I want to find the probability that Lexi goes to class once, then I'm going to change my R to 1. So that'd be now to the first power, 0.4 to the new n minus r. 3 minus 1 is 2, so the exponent there is 2. And I'm just going to go back in and type that in my calculator. So when I type that in my calculator, we get, oops, 1 second, still working on it, 0.288. Now, since this is the probability of going to class 0 times and the probability of going to class once, if you add them up, that's the probability that Lexi gets 0 points, because those are the 2 circumstances in which she would get 0 points. So that's plus 0.064 equals 0.352. So 0.352 is the probability for her getting 0 points. Now, you can either get 10 points 2 different ways. You can do the same exact thing and just add them up. So combination of 3, choose 2, and then do 0.6 to the 2, 0.4 to the 3 minus 2, which is just 1, and get that answer, and then add it with the combination of 3, choose 3. This is the going to class twice and going to class 3 times. 0.6 to the third power, and then 0.4 to the 3 minus 3, which is 0 power. If you get these 2 answers and you add them up, you can get the probability that she gets 10 points. The other way you could do it is just, because there's only 2 outcomes here, if you know this outcome already, just subtract that from 1, and that'll be the difference, and that'll be the probability for 10 points. So I'll let you guys work on that. I'm not going to give you the answer on this because cheaters. Okay, anyway. Number 4, an aquarium contains 7 fish, 3 fish that weigh 200 grams each, 2 fish that weigh 150 grams each, and 2 fish that weigh 100 grams each. 3 fish are selected at random, and a random variable x is defined by associating with each outcome the total weight of the 3 fish. Find the density function of x and find the expected value. So if density function, remember, is just my table. So table x, my random variable, and then the probability associated to that. So I'm choosing 3 fish, and my random variable x is defined by associating with each outcome the total weight of the 3 fish. So let's think about how many different ways I can choose my 3 fish. So remember, there are 3 that weigh 200. There are 2 that weigh 150. And there are 2 that weigh 100. So these are the 7 different fish weights. So I could choose all 3. I'm choosing 3 fish. I could choose all 3 that are 200. So if I do that, that's a total weight of 600 grams. So 600 is one total weight. I could choose 2 fish that are 200 and then one that's 150, which would make 550 as my total weight. I could choose 2 200s and 1 100, which would mean a total of 500 for weight. 200 plus 200 plus 100 is 500. I could choose 1 200 pound, or not 200 pound, 200 gram fish, and then the 2 150s. Those 3 fish combined would weigh 500 as well. So we're going to have to remember that when we find our probabilities. That you could have 1 200 gram and then 2 150 grams. So I'm going to make a note of that. So this was 2 200s plus 1 100 and or the other way could have been 1 200 and the 2 150s. So we're going to need to know that when we do our probabilities. So that's for our 500 gram fish. I could choose a 200 with both, with a 100 and a 150. I could choose a 200 and one, basically one of each, which would weigh 450. I could choose a 200 with both these 100s, which would make 400 total weight. I could choose, and I think this is the last one, 2 100s and a 150, which would make a total weight of 350. So I believe those are all the different possibilities. If you think of more, let me know. But we should be able to know this when we start working out the problem if we've missed any. So the probability now of choosing, let's say, the 600 pounds. So remember, 600 pounds was all 3 of them were the 200, or not, I keep saying pounds, but it's grams. All 3 of them were the 200 grams. So remember, you're choosing 3 fish out of how many that are here? 7. There are 7 in total. You're choosing 3. So if you want to know the total number of ways, there's 7 in total. You're choosing 3. So this will give you the total number of ways to choose 3 fish from the 7. And all of these added up should equal that number, because that is the total number of ways. And I believe, let's go ahead and calculate that, because I'm not 100% sure what it is right now. Combination 7, choose 3. That's 35. So there are 35 different ways for each of these. Kind of ran out of room. I thought I made this big enough for the problem, but I clearly didn't. So 600 pounds, 6 grams, man, okay, is 3 of the 200 ones. So that's a combination of, there are 3 200 gram fish, and you're choosing all 3 of them, multiplied by the combination of the two 150, but you're choosing none of those, and the combination of the two that are 100, but you're choosing none of those as well. I'm going to put all three of them here just to emphasize the point that this says this accounts for the 200 grams, this accounts for the 150 grams, and this accounts for the 100-gram fish. So there are 3 200-gram fish, and I'm choosing all 3 of them in this first probability I'm looking for, which means that of the 2 150-gram fish, I'm choosing none of those, and of the 2 100-gram fish, I'm choosing none of those as well. Now, both of those equal 1, so they're basically irrelevant because I'm choosing none of those fish. So really, just this would be the probability, which either way, the answer is 1. So it's only 1 out of 35 for the probability. So a 550 occurs when I choose 2 200 grams and 1 of the 150-gram fish. So now that probability would be the combination. Let me go ahead and erase this. So that's a combination. There are 3 200-gram fish, and you're choosing 2 of them. And your combination of there are 2 150-gram fish, but you're choosing 1 of them. And again, the combination of 2 100-gram fish, but you're choosing none of them. And again, this is irrelevant because that 0 basically means it's not going to do anything. So just this is really all you need, which that is, believe 3 is the, no, 6. Let me just double check that. Pretty sure it's 6. Let's just verify it for you. Yeah, 6. So that is 6 out of 35. Now this is the hard part of the problem, is the 500, because 500 occurs 2 different ways. So we're going to have to add them both up. So I've already written those 2 different ways because I didn't want to forget them. But 2 200-pound fish, that's a combination, or gram, jeez. All right, 3, choosing 2 of those, and then I'm multiplying it with the combination of the 100-gram fish, which there are 2 of them, and you're choosing 1. We're going to take this, and we're going to add it with this other outcome. So combination of a 200-gram fish, there are 3 of them, that's 1 of them, and then multiply that with the combination of 2 150-gram fish, and you're choosing 2 of them. So again, if you're confused where those numbers are coming from, so remember this is one way to get 500 total grams, and this is the other way to get 500 total grams from the fish that you choose. So this first way is 2 fish that are 200 grams each, which remember, there are 3 fish that weigh 200 grams, and you're choosing 2 of them, so that's where that comes from, combined with the 100-gram fish. So there are, remember, 2 fish that weigh 100 grams, so that's where that 2 comes from, and then you're picking 1 of them in this situation. So that's where those probabilities come from. So when you multiply them together, that is going to be 6 right there. And then this other one says, okay, 1 fish that's 200 grams, remember, so there are 3 that weigh 200, and you're picking 1 of them. And then 2 of the 150, so there are 2 in total that weigh 150, and you're choosing basically both of them, choosing 2 of them, just to explain where those numbers come from again. So that is 3. So 6 plus 3 makes 9 weighs in total. All right. So let me erase that because I don't need it anymore. Combination of 450. So 450 was 1 of each, right? A 200, a 100, and a 150. So a 200, a 100, and a 150. So that's a combination of 3. Choose 1 because there are 3 200-gram fish, and you're picking 1 of them, multiplied with the combination of 2, choose 1, and 2, choose 1. Because there's 2 100-gram fish, and you're choosing 1 of them. There's 2 150-gram fish, and you're choosing 1 of them. And that all multiplied together is 12. 400. So 400 occurred with the two 150s and the 100. One of the 100. So that's a combination of two choosing two, because there are two 150-gram fish and you're choosing both of them, multiplied with, so the plus sign is kind of confusing. All right. Multiplied with the combination of two choose one, because there's two 100-gram fish and you're choosing one of them. So that is 2, I believe. And then the last one, the 350, is the two 100s and one 150. So two 100-gram fish and then one 150-gram fish. So that's a combination of 2 choose 2 multiplied with the combination of 2 choose 1, which makes the answer 2. So hopefully I did this right, and these all add up to 35. So 1 plus 6 is 7. 7 plus 9 is 16. 16 plus 12 is 28. 28 plus 4 is 32. I must have missed one. Did I miss one? Might have missed one. I'll have to come back to that. If you guys are screaming at me, it's probably well deserved. I bet one of those is duplicated, and I can't remember. I can't figure out which one it is. So this is why you work the problems out before you make the video. Oh, whatever. Let's see here. 200, 150, 100. I don't know. I'll have to figure out what I skipped, and I'll come back to you on that one. But at least you get the idea of how the problem is done, even though I kind of suck at doing them. All right. Yeah, I don't want to re-record this video because I'm already this long in. So anyway, the rest of this wraps up pretty easily because it's in our calculator. So for each of the following pairs, N and P, check if the normal approximation for the binomial is valid. So to check to see if it works, all we have to do is N times P has to be greater than 5, and then N times Q, if you want to think of it as Q, but we called it 1 minus P, is also bigger than 5. If both those statements are true, then it works. So for the first one, N is 20 and P is 0.1, so 20 times 0.1 equals 2. And since that is not bigger than 5, the answer for A is no. Don't even have to worry about doing it on the other part of this because it wouldn't matter. All right, so 15 and 0.7. So N times P, 15 times 0.7 equals 10.5, which is fine, and then 15 times 1 minus 0.7, which is 0.3, is 4.5. So the answer there would be no, sadly. So, I mean, you guys can handle how to do this, I think. So I'm just going to move along and let you guys answer them because it's basically just plugging in the numbers and seeing if it's bigger than 5 or not. So let X be a standard normal random variable. Find the probabilities here. So this is just going in your calculator and hitting the second vars, which brings you to your distribution, and choosing normal CDF, and just putting in the 4 values: your lower bound, your upper bound, your mean, and your standard deviation. Now, these all tell you what your lower bound and upper bound is. So those are pretty self-explanatory for these problems, except for maybe C and D. So obviously for A, this is your lower bound, that's your upper bound. But what's the mean with standard deviation? Well, it doesn't say. It says standard normal random variable. And when it says standard normal random variable, that means the mean is 0 and the standard deviation is 1. So you need to memorize that. You need to know when you see standard normal that that just translates into this information. It's telling you that the mean is 0 and standard deviation is 1. So you type that in the calculator with those lower bounds and upper bounds, and you'll be just fine. Now for C and D, it says x is less than 0.7. So that is basically all the way from negative infinity to 0.7. So your lower bound in that case would be negative infinity, which remember in the calculator we would type in negative 1 E99 and then the upper bound 0.7. And the other one is x is greater than 0.5. So that means the lower bound is 0.5, which means the upper bound is positive infinity. Positive infinity would be positive 1 E99. That's how you would type that in the calculator. So moving on. Number 7, same thing, but it tells you what the mean is and what the standard deviation is, and it tells you the lower and upper bounds. So again, just go to second vars, normal CDF, and you'll figure it out. Let y be a binomial random variable with n equal to 162 and p equal to 1/3. So find the mean and standard deviation. So remember, the mean formula is just n times p. This is like your expected value. So if you multiply 162 times 1/3, you'll have the mean. Standard deviation is the square root of n times p times 1 minus p. So again, plug in those numbers and get that value out. Those will tell you the mean and the standard deviation. And then once you know what the mean is and the standard deviation, you've just got your lower and upper bound to plug into that second vars and normal CDF calculator function. So it'll be this number is your mean, this number is your standard deviation, whatever you got when you equated those, and then your lower and upper bounds. You'll be just fine. Let x be a random variable. Let y be defined with the formula y equals x minus 88 over 9. Find the probability x takes values between 75 and 105. So again, this is just typing in our calculator, going to second vars, going back to normal CDF, and then typing in your lower bound, your upper bound, your mean, and your standard deviation. So lower bound and upper bound, pretty obvious, 75 and 105. But remember, this is our mean and standard deviation because the formula x minus the mean over the standard deviation. This is telling us that 88 is our mean and 9 is our standard deviation. So if you can read that, it says it right here. It doesn't say it explicitly, but it just says it like there. That's telling you what the mean is and what standard deviation is. So just go with it. Type it in the calculator and be done. Number 10, the Tampa Bay Rays. Again, I don't know who makes this type of question because I certainly don't. Okay, play 162 games in a season. The probability they win a given game is 0.55. What's the probability that Rays win at least 90 games? What is the probability the Rays win 80 to 90 games? So remember the n times p thing because this is what that's referring to. N is obviously 162, and then probability of success is 0.55. So if you want to know what the mean is, it's n times p, which means 162 times 0.55. That number is your mean. Your standard deviation is the square root of n times p, 1 minus p. So whatever that is your standard deviation. So you calculate those numbers, and you'll have your obviously mean and standard deviation, which you'll plug in the calculator back into this function. So, and then you use your lower and upper bound. So B is pretty simple in terms of what your lower and upper bound is. So I'm not going to explain that. But A, at least 90 games, lower bound is 90. And then upper bound could be all the way up to 162 because if they go undefeated, which, that's happened in baseball before, right? Totally. That would make sense. So your lower bound is 90, it's at least 90, and your upper bound 162. All right, so Mary Beth loses participation points each week in math class. It loses an average of 3 points each week with a standard deviation of 1 point. Find the probability Mary Beth loses between 3 and 5 points this week. Oh man, how did they know though? That's incredible. All right. So it tells you what the mean is. The mean is 3, the standard deviation is 1, and then you're looking at the probability between 3 and 5. Now actually, well, it shouldn't really matter. But you could use the mean as -3, and then the lower bound is -5 and upper bound is -3, but I think it should be the same way. I'll let you guys experiment with that. So try it on your calculator, see if it works. With the lower bound of 3 and the upper bound of 5. And also try with the mean of -3, standard deviation would still be 1, that wouldn't change. A lower bound of -5 and an upper bound of -3. And tell me if that works, if those values are the same. I'd be curious to know if they are. I think they would be, but you never know. Anyway, don't expect that one on the test. That's just mean. All right, 12. A Major League Baseball player has a batting average of 0.2. If the player's turns at bat are viewed as Bernoulli trials with P equal to 0.2, because that's basically repeating this. What is the probability that in 200 times at bat, he has at least 50 hits? So it's kind of like the Rays problem in a way. So the mean is N times P, which in this case, N is going to be your 200 times, and then your probability of success is at 0.2. So that's your mean. Your standard deviation is the square root of N times P times 1 minus P. Get that value. And then your lower bound is 50, of course, because you want at least 50 hits. And your upper bound would be the max, I guess, in terms of hits. So you hit all 200. Probably unlikely, but that is your upper bound. So anywhere between 50 to 200, you're looking for that probability because you want at least 50 hits. And that's your math. I'm not going to give those answers because, again, that's just typing in the calculator. I'm going to end the video, guys. If I fix this problem up here with the fish, I'll let you know. I'll just make like a quick 3-minute video and just fixing it. But I'll do that in a different one. I don't want to waste your time on this one. So I'll let you guys, I'll let you know. All right. I'll see you later. Bye.